Hello everybody. How is everything going? In this part 8 of the series, we are gonna discuss determinants of 1 by 1 and 2 by 2 matrices. As we discussed in the previous sections, matrix is denoted by either this square bracket or this round bracket, but the symbol we use for denoting determinants is this parallel vertical lines, which is also the symbol for denoting absolute value equations. How do we identify whether the symbol stands for determinant or an absolute value? The answer is simple. If the entities inside those parallel vertical lines are rectangular array of numbers, that symbol stands for determinant, otherwise it stands for absolute value. Determinant is a scalar value that's a function of entities of a square matrix. From this definition, we can understand that the determinant can be solved only for square matrices. That's 1 by 1, 2 by 2, 3 by 3, or some other higher order square matrices. In this part and in the upcoming parts, we will see how to solve the determinants of matrices starting from 1 by 1 matrix, and then we will dive deep into some higher order matrices. If matrix A equal to this 1 by 1 matrix, then determinant of matrix A equal to the element of the matrix, that's A. No need to put your pen to paper for calculating the determinant of 1 by 1 matrix, because the determinant of 1 by 1 matrix is simply the element of the matrix. For example, if matrix A equal to this 1 by 1 matrix with an element -4, then the determinant of matrix A equal to -4. When we move to 2 by 2 matrices, if matrix B equal to this 2 by 2 matrix with an element of first row A, B, and elements of second row C, D, then the determinant of matrix B is equal to AD minus BC. For calculating the determinant of 2 by 2 matrix, multiply this first row, first column and element by this second row, second column and element, that's main diagonal elements, and deduct from this result the product of the remaining two elements. For example, if matrix B equal to this 2 by 2 matrix, then determinant of matrix B equal to the product of the elements of the main diagonal, that's 1 times 6, minus the product of the remaining two elements, that's 5 times 3, which is equal to 1 times 6 is 6, minus 3 times 5 is 15, 6 minus 15 is -9. Another example, the determinant of this 2 by 2 matrix is equal to 6 times 5 minus 1 times -2, which is equal to 6 times 5 is 30, minus 1 times -2 is -2, which is again equal to 30, minus -2 means +2, so 30 plus 2 gives us 32. Let me add one more. Determinant of a matrix with first row elements 2a minus 2b, a minus 4b, and second row elements 4a plus b, 2a plus 2b is equal to the product of main diagonal elements, that's 2a minus 2b times 2a plus 2b, minus product of the remaining two elements, that's 4a plus b times a minus 4b, which is equal to 2a times 2a is 4a squared, 2a times 2b is plus 4ab, minus 2b times 2a is minus 4ab, minus 2b times 2b is minus 4b squared for the first product, minus 4a times a is 4a squared, 4a times -4b is minus 16ab, b times a is plus ab, b times minus 4b is minus 4b squared, which is equal to plus 4a minus 4a equal to 0. So what we left with is 4a squared minus 4b squared minus -16ab plus ab is -15ab. So what we left from the second expression is 4a squared minus 15ab minus 4b squared, which is equal to 4a squared minus 4b squared as it is. This negative times 4a squared gives us -4a squared. Again, this negative times -15ab is plus 15ab. This negative times -4b squared is plus 4b squared. This implies 4a squared minus 4a squared is 0, and -4b squared plus 4b squared is also 0. So what we left with is 15ab. Let the determinant of this 2 by 2 matrix is 2. Calculate the two whole numbers x and y, given that x is 2 more than 3 times y. Here, we are asked to solve for two variables, that's x and y. For solving these variables, we need to have two equations. The first equation can be derived from the given mathematical relationship between variable x and variable y. As it is stated in the given, x is 2 more than 3 times y. This means x can be determined by adding 2 on 3 times y, that's 3y. So this variable's mathematical relationship can be expressed as x equal to 3y plus 2. This is our first equation. The second equation can be derived from the determinant, that's the product of main diagonal elements, that's x minus y times x plus y, minus the product of these two elements, that's 1 times 2, that gives us 2, which is equal to 2. This implies x minus y times x plus y. Taking negative 2 to the other side of equality becomes positive 2. So positive 2 plus 2 gives us 4. We already determined that x equal to 3y plus 2. So substituting 3y plus 2 in place of x, we will find 3y plus 2 minus y times 3y plus 2 plus y, which is equal to 4. 3y minus y is 2y plus 2 times 3y plus y is 4y plus 2, which is equal to 4. Both the coefficient of y and the constant term in each of these left-hand side expressions are the multiples of 2. So taking 2 as a common factor, we will find 2 times 2y divided by 2 is y plus 2 divided by 2 is 1 times, for the second expression, 2 times 4y divided by 2 is 2y plus 2 divided by 2 is 1, which is equal to 4. 2 times 2 is 4. 4 divided by 4 gives us 1. As the left side of equality, we left with y plus 1 times 2y plus 1, which is equal to 1. Y times 2y is 2y squared plus y times 1 is y plus 1 times 2y is 2y plus 1 times 1 is 1, which is equal to 1. 2y squared plus y plus 2y is 3y plus 1. Taking this one to the left of equality, we will find minus 1 equal to 0. This implies 2y squared plus 3y. 1 minus 1 is 0, so no need to add 0. This simply equal to 0. Y is common for both expressions. So taking it as a common factor, we will find y times 2y squared divided by y is 2y plus 3y divided by y is 3, which is equal to 0. This expression equal to 0 only when either y equal to 0 or 2y plus 3 equal to 0. Taking 3 to the right of equality and dividing by 2, we will find y equal to negative 3 over 2. As it is stated in the problem, both x and y are whole numbers. So y equal to negative 3 over 2 can't be a solution because negative 3 over 2 is not whole number, rather it's negative integer. Thus y equal to 0 is the only value of y. In the first equation, we figure out that x equal to 3y plus 2. Substituting 0 in place of y, we will find x equal to 3 times 0 plus 2. 3 times 0 is 0. 0 plus 2 gives us 2. So the answer is x equal to 2 and y equal to 0. By this, I conclude this episode. Stay safe.